Okay, let's do one example. The MSCI EAFE, Europe, Australia, and Far East Index, is a free float adjusted market capitalization index designed to measure developed market equity performance excluding United States and Canada. So the EAFE index consisted of 16 European markets, 2 Australian, 3 Far East, and Israel. Overall, 22 market indexes. Now, this is the European section of the index. The total returns for European markets in 2012. And as you can see, we have 16 European countries. And the total return is in local currency. So it's not the return that any single investor would earn because it is not stated in a single investor's currency, right? And although that most of them they have like the currency is euro, but we got Swiss franc in there and British pound. So anyway, that's not the point. So we have total returns for 16 European countries, and we want to find out the mean of our sample, the median, and mode. To find the mean, well, it's pretty simple. I feel weird writing it out. It's just that we add up all these returns, then we divide by the total number, which is 16. So our sample mean would result in, 11.68%. I'll write it over here also. So 11.68%. Okay, so that's our mean. Now, with the mean, you should not expect any of your returns in your data to, exactly match the mean, right? So the mean could be a totally different return. Now, the other thing that you can verify if you count it exactly, out of the 16 observations, 16 returns, exactly 8 of them lie above the mean, 8 of them lie below the mean. And like I explained before, it just happened to be that way in this example, but it's not going to be the case all the time. I explained in a simple example, so I hope you remember that. And by the way, since we are examining characteristics of some units in a specific point in time, 2012, so we are dealing with cross-sectional data, that is our cross-sectional mean, right? Now the mean provides a good summary of our data, and we can use the mean the sample mean as a measure of the typical outcome for a distribution. That means if you were to invest in the European market index, you would expect to have a return close to the mean, right? And the other good thing about the mean, and you should always use it in your report, is that you can use the mean to compare the performance of two different markets, let's say. Here we are analyzing the European market, and we found the sample mean. Maybe you can compare that to the Asian market. So that will be a good measure for comparing performance of investments in different markets. All right, great. Now, before we do median, let's deal with the mode first. Let's take a look at all our returns. Do you see the mode? Do you see any frequently recurring value? No, right? All the returns are different. So we have no mode, right? When all the values in a data set are different, the distribution has no mode because no value occurs more frequently than any other value. So here that will be no mode, right? Okay, but if we were to group data into intervals, do interval analysis, like that frequency distribution, remember? If we do that, more often than not, you will see one interval that contains the most number of returns. Let's say if you would break our range here into intervals with a width of let's say 5%, at least a few return will fall into one interval, right? So more often than not, you will have a modal interval. But when you're dealing with returns like this, it is possible that you have no mode, because all the returns are different. Okay, let's deal with our median now. Now, before we deal with the median, what should we do with our data? If you can recall, we should sort the data, right? In the ascending or descending order, doesn't matter. Now, this is the data sorted. We have Spain with the lowest return, minus 4.76%, and Belgium with the highest return, 33.99%. Great, we have the data sorted. Now, the our n here, the total number of observation, is 16. So we are dealing with an even numbered sample, right? And what do we have to do when we are dealing with an even numbered sample? We have to find the average of the two of the middle observations, right? So that will be n divided by 2 plus n plus 2 divided by 2, and we find those positions, then everything over 2, we find the average of those, right? So the middle items would be n divided by 2, that will be 8, that will be Finland, and this one would be Sweden. So I'll write it over here, 8.27 plus 12.66, everything over 2, that will give me 10.45. Okay, so 10.46%, that will be my median. Okay, now as you can see here, the median is not influenced by the outlier. So if, let's say, the return for the Spain was even lower than this, lower than minus 4.76, still it would not affect my median, right? Or even if the Belgium return was even larger than this, still the outlier, no effect on the median. So there you go, you have your mean, median, and no mode. Okay, let's do another example. Median and arithmetic mean, the case of the price to earning ratio. So let's say you were asked for a valuation for a 7-stock portfolio, and these are US common stocks, by the way, so you've got 7 of them. Caterpillar, Ford Motor, General Dynamics, all the 7 of them. And they have asked for your valuation. All right, great. So let's see what we got here. They've given us consensus current EPS and consensus current PE. EPS stands for earning per share, and PE ratio is we've got the price in the numerator, and the denominator E is actually earning per share. And I'm not going to talk about PE and EPS here because you will see it in the equity valuation section of the course. So back to the example, and by the way, the stocks are equally weighted in the portfolio. That means we have invested the same amount of money in each of these stocks. They have also given us the average current PE on the companies in the S&P 500 index, which was 18.80 at that time, which was 2013, I think. So we have to calculate the arithmetic mean PE, calculate the median PE, and then evaluate both of them to see which one is a better measure of central tendency, which one makes more sense. So to calculate the arithmetic mean, pretty easy. Again, just add up all the observations here, then divide by 7 because that's the number of observations. We do that, and the mean comes out 42.49. Okay, so that's our mean. Now, in the case of median, what do we have to do before calculating the median? You got to sort the data. This is the data sorted. Our lowest PE belonging to Ford Motor Company, and then the largest PE belonging to Click Technologies, right? And as you can see, we have 7 observations, so we are dealing with an odd number of observations. So that makes it a lot easier to calculate the median. So our n is 7, right? To calculate the median, n plus 1 divided by 2, that'll be 8 divided by 2, 4. So we're looking for the fourth observation. Yeah, this is our median. Okay, great. So let's evaluate. Now, let's start with the mean, arithmetic mean. As you can see, the mean, here that the data is sorted is pretty clear. The mean is larger than, out of the 7 observations, 6 of them are less than the mean. Only 1 observation is, more than the mean, right? And that belongs to the click technology, right? So this is our outlier. The rest of the observations are, somewhat close. But this one is, like an outlier. So that's why the mean kind of leans toward that outlier. And that's why when you compare it to the 18.80, the current PE of the S&P 500, this is much larger than this one, right? So if we're looking for the central tendency, maybe this is misleading, right? Now the median, on the other hand, looks much more reasonable than this one because it's not affected by the outlier, right? So the median PE of 13.94 appears to better represent the central tendency of the PEs. And as for the mean, if we were to, trim these observations, let's say get rid of this click technology as the largest PE and also the lowest Ford Motor, if we get rid of these two and then calculate the mean, then our mean will come out even lower than the S&P 500 index. So excluding the largest and the smallest PE stocks would result in a mean that is going to be below the average PE of 18.80 for the S&P 500 index. Anyway, in this case, median appears to be a better measure of central tendency.